Rosenblatt was at Cornell. I was at Stanford. And the perceptron was a learning machine. And my little learning machine I call ADALINE, adaptive linear neuron. So I had a single neuron that's adaptive, and I'll show it to you. I still have the original ADALINE that I carried in my suitcase to take to Cornell to meet with the perceptron with Professor Rosenblatt. This machine is a single adaptive neuron. So you talk about machine learning, this is the most elemental machine that learns. It's right here. This was built in 1960. We call it ADALINE, an adaptive linear neuron. We're able, with these switches, to put in input patterns. For example, here's the pattern X. This switch provides input to that weight, this switch to that weight, this switch to that weight. What the meter is reading is the sum. So take this, whatever the value that is, and multiply it by whatever value this is, plus whatever value this is, multiplied by that, and this by that, and this by that. So we put this in, here's +1. Now you're going to take this and multiply by that weight. I set it to 0. But if you do that, you can see they're going up. They go back to 0 and go the other way. See? I'm going to train it for an X pattern to give a positive response, a +1 output. So this is positive, so I want to make the meter go that way. This is positive, so I go positive. Negative, negative, I go negative. Positive, positive, negative, positive, positive, negative, negative, positive, positive, negative, positive, negative, negative. I desire for this input pattern to train it to give a plus response. So we're training it. So there's a T pattern, and let's say we wish the T pattern to be negative. What that means is that wherever the switch is up positive, to make that go more negative, you make this go the opposite. So if this is positive, you make that go negative. So we're getting a strong response for the T. Negative is what we wanted. Now let's put back the X. X is positive and T is negative, so it separates the two. We trained it.